roughly 85% accuracy in terms of doing facial recognition. Now, we as humans can do about 97.5, 98% accuracy in terms of seeing someone's face and knowing who that person is, assuming we have met that person before, of course. In 2015, a couple years after acquiring Face.com, Facebook rolled out something called Deepface, which is as creepy as a name as it is what it does. It's a terrible name. Deepface was Facebook's implementation of what they bought, the algorithms and the IP they bought with buying Yaniv's company, Face.com. My speaker notes actually right now say creepy name, creepier results. So, first of all, it worked a little bit better than the FBI system, which they spent, they've estimated close to $1 billion on. It's around 97.2% accuracy, again, as far as Facebook has publicly announced or published in some of the journal articles. It's basically as good as humans are. And in fact, in many circumstances, it's starting to outperform humans' ability to recognize faces, which is also kind of creepy. Here's where it gets awesome, and you may want to increase your passwords. They trained it with about 4 million images from 4,000 users. That was kind of the first training set to start training the machine learning algorithms. No one was told whether they were one of those 4,000 users, which is awesome. Somewhere buried in one of those agreements where you clicked I agree really quickly, you kind of said, okay, you can use all the pictures I've ever uploaded and all the tags I've done and learn from that. They do it with all images now, so if you use Facebook, you actually can't opt out anymore. Technically, for the technical-minded folks in the room, it's a 9-layer neural network. It's got about 120 million connection weights, so it's a very, very complex learning network. It's based on deep learning, which we will kind of get into a little bit. In terms of the training and the ongoing training, people are uploading 400 million photos a day on average to Facebook, which is a stupid number of photos. Every time we manually tag a photo, we are feeding information to Facebook, which further trains and tunes the algorithms to know who each face is. The really, really awesome part, again, for the more technically minded folks, you can represent the face in the form of a hash. It can be done in a 32-byte hash. So it's a very, very small amount of memory or computing space you need to actually store a hash that you can use to uniquely identify a face. So what does that mean? It means we can store roughly, if you do the math, 7 billion faces in 256 gigabytes of space. One of these. Who here has gotten a loan before of some kind? Cool. So you all know what a loan is. Someone gives you money. In exchange for that money, you pay them a certain rate of interest. Now, if you are a less reliable human being, you might pay more interest because the person lending you the money may not trust that you will repay them. If you are a very reliable person with a great track record, you may pay very little interest because the person lending you the money or the institution is sure that you'll pay them back. The idea here is, can we actually predict whether or not someone will pay back a loan? So Barclays, which is a bank in the UK, put out a data set. It had 100,000 records, and it had 800 variables for each record. Some of the variables were actually junk. They didn't tell people. They kind of took away. Imagine a spreadsheet, 100,000 rows long, 800 columns wide, and then they went and they were kind of dicks and they deleted the header row, which said what variables was what. They put that data set out and said, figure out which of these people defaulted on their loan, which ones paid back their loan, and the ones who defaulted, by how much. So this is kind of what the data looked like. So we know there are two types of people. We ended up finding out that about 10% defaulted. The objective was to figure out which people defaulted and what was the loss. So by how much did they not pay back their loan? We had 800 variables to go through. Using the 100,000 records we had, we were able to train the deep learning algorithm. We got 99% accuracy on predicting whether or not someone defaulted or not, and about 96% accuracy by how much. So what happened was we put the 100,000 records in, we trained the data set, and then we were given another set of data which didn't tell us the answer, and we got another 10,000. We tested this against that final 10,000. So we got pretty good results, and now you can start to see why this matters. For an organization like a bank, this is incredibly valuable. Now we could actually know in advance what interest rate to charge someone. We are going to bring this back to how to design better interfaces. The really, really cool part, which I will just briefly share, is we discovered that only 6 of the 800 variables mattered to a significant degree. So if we took all 800 pieces of information about a record, we got a 99% chance of guessing right. If we took the right 6 variables, we earned about 97.5% accuracy. So with a lot less information, but the right information, we are able to get still very, very good results. I'm not going to talk about the topological data analysis. I meant to hide this slide. It's a really cool looking slide, so it's pretty. Basically what it says, though, is that that 96%, so our accuracy on how much we defaulted by, it kind of starts to break down when we started moving out of like car loans in the $10,000, $20,000 range, and we got to mortgages for the $400,000 range. So if we actually separated out a few categories of loans, we got much better results. The second we had very mixed data sets that had such a broad range of loans, it was really hard to get the accuracy high.